Welcome to another exciting episode of Astronomy Daily. We have a fascinating lineup of stories for you today, packed with groundbreaking discoveries and remarkable achievements in space exploration. We'll delve into new research that finally answers whether Venus, often called Earth's twin, ever had oceans on its surface. Then we'll explore an extraordinary breakthrough in gravitational wave mapping that's giving us unprecedented insights into the architecture of our universe. We'll also look at China's latest milestone in satellite technology, catch up on an incredibly busy week of space launches, and follow Bepi Colombo's latest encounter with Mercury that's bringing us haunting new images of the solar system's innermost planet. Stay with us as we journey through these remarkable developments in space and astronomy that continue to expand our understanding of the cosmos. Let's get started. Recent research has provided compelling evidence about Venus's ancient history, definitively answering whether our planetary neighbor ever hosted oceans. The study, published in Nature Astronomy, examined the chemical composition of Venus's atmosphere to determine the water content of the planet's interior, a crucial indicator of its past conditions. The findings paint a stark picture of Venus's history. By analyzing volcanic gases in the planet's atmosphere, scientists discovered that Venusian eruptions contain no more than 6% water vapor, a dramatic contrast to Earth's volcanic emissions, which are more than 60% water vapor. This indicates that Venus has always had a substantially dry interior, suggesting the planet never experienced the conditions necessary for oceans to form. The research challenges previous hypotheses about Venus potentially harboring a hidden reservoir of water beneath its surface, a remnant of a lost ocean. Instead, the evidence supports the theory that Venus remained parched after its early molten rock phase, never developing the conditions we associate with habitability. While Venus and Earth are often called sister planets due to their similar size, mass, density, and distance from the Sun, their evolutionary paths diverged dramatically. Today, Venus presents extreme conditions that bear little resemblance to Earth, with surface temperatures reaching 465 degrees Celsius, atmospheric pressure 90 times greater than Earth's, and toxic clouds of sulfuric acid. This research provides valuable insights into planetary evolution and the factors that determine habitability. It suggests that Venus's current hostile environment isn't the result of losing its oceans over time, but rather reflects conditions that have persisted throughout most of its history. The findings help us better understand why Earth and Venus, despite their initial similarities, developed such dramatically different environments. In a groundbreaking development, Australian astrophysicists have created the most detailed maps of gravitational waves ever produced, offering unprecedented insights into the universe's most massive black holes and their cosmic influence. Led by Matt Miles from Osgrav and Swinburne University, this international effort has revealed a more dynamic and active universe than previously anticipated. The mapping project utilized the MeerKAT Pulsar Timing Array, the largest galactic-scale gravitational wave detector ever built. By observing pulsars, rapidly spinning neutron stars that act as precise cosmic timekeepers, researchers could detect minuscule changes caused by gravitational waves with remarkable nanosecond-level precision. One of the most intriguing discoveries is an unexpected hotspot in the gravitational wave signal. According to Rowena Nathan from Osgrav and Monash University, this hotspot could indicate the presence of a pair of black holes billions of times more massive than our Sun. This finding challenges the previous assumption that the background signal would be uniform across the sky. The team's observations captured a stronger signal of background gravitational waves than similar global experiments, and remarkably, they achieved this in just 1/3 of the time. This enhanced detection capability opens new possibilities for studying the echoes of cosmic events that occurred billions of years ago. These maps serve as a powerful tool for understanding the universe's structure and evolution. They're helping scientists track the locations and numbers of merging supermassive black holes, explore the origins of these cosmic giants, and even provide insights into major events from our universe's early history. This research represents a significant step forward in our ability to observe and understand the gravitational architecture of our cosmos. China has marked a significant milestone in satellite technology with the successful deployment and handover of APSTAR 6E, their first all-electric propulsion telecommunications satellite. This achievement represents a major advancement in satellite operations and demonstrates China's growing capabilities in space technology. The satellite, developed by the China Academy of Space Technology, operates from geostationary orbit using the advanced DFH-3E platform. What makes this satellite particularly noteworthy is its innovative propulsion system. Rather than traditional chemical propulsion, it relies entirely on electric propulsion technology to maintain its orbital position and make adjustments. Launched earlier this year aboard a Long March 2C rocket from the Xichang Satellite Launch Center, APSTAR 6E successfully transitioned to its geostationary orbit, using only its electric propulsion systems after separating from its propulsion module. This approach not only demonstrates remarkable efficiency, but also represents a more cost-effective method of satellite deployment. The satellite, which has been designed for a 15-year operational lifespan, is now being operated by Hong Kong-based APSTAR Alliance Satcom Limited. Its primary mission is to provide affordable, high-throughput broadband communication services with a particular focus on serving customers in Indonesia. This technological advancement not only showcases China's growing expertise in satellite technology, but also represents a significant step forward in making space-based communications more accessible and sustainable. This successful deployment adds China to a select group of nations capable of developing and operating all-electric propulsion satellites, marking another significant milestone in the ongoing evolution of space technology. Space launch activities are reaching a fever pitch this week with an impressive lineup of 10 orbital launches planned. SpaceX is leading the charge with an ambitious schedule of 5 Falcon 9 launches in just 5 days, showcasing the company's remarkable launch cadence capabilities. 4 of these SpaceX missions will be dedicated to expanding their Starlink satellite constellation, while the 5th will carry SXM-9, a digital audio-radio satellite for SiriusXM. These launches will take place from both coasts of the United States, utilizing launch facilities in California and Florida. China is maintaining its strong presence in space activities with 3 launches scheduled this week. While details about some of these missions remain classified, we know they'll be using various vehicles from their Long March rocket family, including their newer Kuaizhou 1A quick reaction vehicle. The European space sector has 2 particularly noteworthy launches on the schedule. The first involves India's PSLV-XL rocket carrying a pair of European spacecraft designed for solar observation. The second is the much-anticipated launch of the Sentinel-1C radar satellite aboard a Vega C rocket from French Guiana, a mission that has faced significant delays following a launch failure last year. Russia is also joining the launch lineup with a planned Soyuz mission from their Plesetsk Cosmodrome, carrying a military satellite designated as Cosmos 2580. This launch had been previously delayed but is now scheduled to proceed this week. Adding to the week's activities, SpaceX's CRS-31 Cargo Dragon spacecraft is scheduled to depart from the International Space Station and return to Earth via splashdown. Once recovered, this vessel will be refurbished for future cargo missions to the station, demonstrating the ongoing benefits of reusable spacecraft technology. This concentrated burst of launch activity reflects the increasingly dynamic nature of modern space operations, with multiple nations and private companies working simultaneously to expand humanity's presence in orbit. The European Space Agency and JAXA's Bepi-Colombo spacecraft has just completed its 5th flyby of Mercury, marking another crucial milestone in its journey to study our solar system's innermost planet. Unlike its previous approach, which brought the probe within just 103 miles of Mercury's surface, this latest flyby occurred at a much greater distance, approximately 200 times farther out. Despite the increased distance, Bepi-Colombo managed to capture another striking image of Mercury standing alone against the darkness of space. This flyby was particularly significant as it marked the first use of the probe's mercury radiometer and thermal infrared spectrometer, known as MERDIS. This sophisticated instrument is designed to measure the planet's surface temperature and composition, helping scientists identify the types of minerals present on Mercury, one of the key mysteries this mission aims to unravel. Bepi-Colombo began its ambitious journey in 2018, launched aboard an Ariane 5 rocket. While originally scheduled to enter Mercury's orbit in December 2025, some thruster issues have slightly extended the timeline, with orbital insertion now planned for November 2026. Once there, the spacecraft will split into 2 separate orbiters. ESA's Mercury Planetary Orbiter and JAXA's Mercury Magnetospheric Orbiter, equipped with 16 different scientific instruments to study this mysterious world. The probe has been using a series of carefully planned planetary flybys since 2020, utilizing the gravity of Earth, Venus, and Mercury to gradually adjust its trajectory. After successful passes of Earth and Venus and previous Mercury encounters in 2021, 2022, and 2023, the probe now has just one more Mercury flyby remaining, scheduled for January 8th, 2025, before it begins its final approach to establish orbit around the planet. And that brings us to the end of today's Astronomy Daily. I'm Anna, and I want to thank you for joining me as we explored the latest developments in space and astronomy. From Venus's ancient mysteries to Bepi Colombo's ongoing mission to Mercury, there's always something fascinating happening in our cosmic neighborhood. If you'd like to stay up to date with all things space and astronomy, head over to our website at astronomydaily.io. There you can sign up for our free daily newsletter and explore our constantly updating newsfeed with all the latest space news. While you're there, don't forget to check out our complete archive of past episodes. Want to be part of our space-loving community? You can find us across all major social platforms. Just search for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Until next time, keep looking up and stay curious about the cosmos.